Let's continue our discussion of the valence shell electron pair repulsion model, and this time we take a 4-electron pair case. This time we take a compound such as methane. Methane has a chemical formula of CH4, and in order to predict the overall arrangement of electron pairs and therefore the molecular shape of methane, we need first to draw a possible lowest structure. And for that, we need to calculate the total number of valence electrons in this case. And in this case, the number of valence electrons from carbon is 4 plus 1 from each of these 4 hydrogen atoms. So the total number of valence electrons is 8. If we divide 8, we get 4 electron pairs. So that's exactly what we do always, is to divide the total number of valence electrons by 2 in order to get the total number of electron pairs in what's to be written as a possible lowest structure. So 8 by 2, okay, that would give us 4 electron pairs. From there on, we draw the central atom, which is carbon, so that's carbon, and the surrounding atoms, and there are hydrogens, and there are 4 of them. And then we draw a single bond between the central atom and each of these surrounding hydrogen atoms. So that's 1, 2, 3, 4. So somebody might ask, is this a possible lowest structure? Well, we can check. So hydrogen, for example, has obeyed the duet rule. It's surrounded by 2 electrons. Carbon, the central atom, is surrounded by 8 electrons. If you calculate the total number of valence electrons used so far in this lowest structure, you would find that there are actually 8, and that's good because we had 8 before. If you also calculate or sum the electron pairs, you would find that there are actually 4, and that's reasonable because you found 4 before. What about the overall arrangement of electron pairs and therefore the molecular shape? Now, the overall arrangement of electron pairs is actually tetrahedral. So that's the overall arrangement of the electron pairs around the central atom, which is carbon. Tetrahedral geometry, okay, looks like that using Darling models. Okay, what about the molecular shape? Well, the molecular shape is based on the positions of these atoms, basically carbon, of course, and the hydrogen atoms and in the molecule. The molecular shape is also tetrahedral. Okay, so if the molecular shape is tetrahedral, and of course the arrangement of electron pairs is tetrahedral, that's because there is no lone pair in this case. Okay, so the molecular shape is also tetrahedral. And the orbital shape or the arrangement of electron pairs and the molecular shape are exactly the same in this case because there are no lone pairs. The bond angle, if you look carefully at the model, it's not actually 90 as somebody might expect. Okay, at the first glance when you look at the lowest structure or the molecular structure, it's actually 109.5. All bond angles are 109.5, and that 109.5 is called the tetrahedral angle. So that's 109.5, which is the tetrahedral angle. To conclude in this case, in the case of methane, this is a 4-electron pair case. All electron pairs are bonding, 0 non-bonding. The orbital shape or the overall arrangement of electron pairs is tetrahedral. The molecular shape is also tetrahedral. The bond angles are all 109.5.